One more quick example before you get into 8.1b. So if I had a 20 here, x here, and a 9 for an, this one's also going to be a little bit weird, but we got, okay, 20 is my mean. My extremes are going to be, now I have to think about it as, okay, one of them's x, but the other one is going to be x plus 9 or 9 plus x, however I want to look at it. So x plus 9. So then when I cross multiply, I get 400 equals, what is that, x squared plus 9x. So then I got to move everything to the same side, x squared plus 9x plus, excuse me, it's minus the 400. I could get the back button to work here, minus 400. So then this time I need to break it down into two factors that will subtract to 9 that multiply to 400. So that should be a 16 and 25, I think. Yeah. So I'll have x plus 25 and x minus 16 should work there. But now I just have to think logically. Only one of those answers actually works, right? I can't have a negative 25 as x, but x could be 16, which makes this whole value x plus 9 25. So the 25 does become a parent, but it's not necessarily going to be useful as a value for x. So when it's all said and done, these are my numbers that I get to work with from here on out. So I could, again, I could solve for a z or a y in here. Z squared would be 9 times 25, which turns into a 15, right? When I square root those things. The y that I might be looking for, I need the mean between 9 and 16, so that's going to be 3 times 4. So y equals 12. Again, you can set up the whole ratio. You can work ahead in your head if you can. But again, when I do the square root of 9 and square root of 16, I get a 3 and a 4. That's why y is 12. But that's just another type of problem you might run into. Throw away any negatives. But if you have two answers that are good, it's probably you could use either of those.